Now see the seventh sum. A cylinder and a cone have equal bases. So this is the cylinder and this is the cone. They have equal bases. Their base is the same. See here, the base is same. The height of the cylinder is 3 centimeters. This is a cylinder. So the height is 3 centimeters. Okay, the height of the cylinder is 3 centimeters and the area of its base. The area of its base is given 100 centimeters. This is the total area of its base is 100 centimeters square. The cone is placed upon the cylinder. Now upon this cylinder a cone is placed. Volume of the solid figure is formed is 500 cubic centimeters. That means volume of the entire figure. Volume of the entire figure is 500 centimeters cube. Okay, cubic centimeters. Find the total height of the figure. Now see here, height of the cylinder is given. This height is given. Height of the cylinder is given. We have to find the height of the cone and then we have to add it. I have to add both the height of the cylinder and height of the cone, and then we will get the total height of the figure. Okay, so what we will do is, first we will say that the cylinder and cone have equal bases. If they have equal bases, that means the radius will also be equal. Okay, first we will say the cylinder and cone have equal bases. Okay, since they have equal bases, their radius will also be the same. That means they have equal radii. So therefore they have equal radii. Okay, so now let it be radius, we will take it as r. Okay, radius we will take it as r. What is the next thing given is over here? Now height of the cylinder is given. Height is given 3 centimeters. So we will write down that height of the cylinder. Height of cylinder is equal to 3 centimeters. If that is given here, height of the cylinder is given. Next, what is given? Area of its base is 100 square centimeters. Area of its base square centimeters. Area of its base. Now we know area of its base. Area of base formula. Area of base is equal to pi r square. Area of base is equal to pi r square. We will write instead of it is equal to 100 centimeters square. Okay. See here. Area of base is given. Area of base is 100 square centimeters. Now below that we know area of base formula. Area of base is equal to pi r square, and this will be as it is equal to 100 centimeters square. Next, what is given? Volume of the solid figure, means volume of this figure is 500 cubic centimeters. So we'll write down that also. Volume of solid figure is equal to 500 cubic centimeters. Okay. Now first what we have done is, we have seen the question here. We have written all that is given. Here we wrote the cylinder and the cone have equal bases. If bases are equal, the radius will also be equal. That is, we have taken it as r. Height of the cylinder is given. We have said height of the cylinder is said to be 3 centimeters. Then area of its base is given 100 square centimeters. We have written all that. Then volume of the solid figure is formed as 500 cubic centimeters. So here we have written everything. Okay. Now after writing everything, what we will do is volume, we are going to add these two. Volume of cylindrical part, volume of the cylindrical part plus volume of the cone. Okay. Volume of the cylindrical part plus volume of the cone. Is equal to, now total volume is how much? They have given you total volume of the solid figure. Whole volume of the solid figure is 500 cubic centimeters. Okay, that means volume of the cylindrical part plus volume of the cone is equal to 500. That is the total volume of the figure. Now we will use the formula for volume of cylindrical part plus volume of cone. That is the conical part. Okay, I have written cone over here. You can also write volume of the cylindrical part plus volume of the conical part. So use volume of cylinder formula. Volume of cylinder is equal to pi r square h. Okay, volume of cylinder pi r square h plus volume of cone. Volume of cone will be 1 upon 3 pi r square h. Okay, see here. Volume of the conical part pi r square h plus volume of cone is equal to 1 upon 3 pi r square h. Okay, is equal to 500. Now see here, we have pi r square here, we have pi r square here. Now what is pi r square? See here, it's given here. Pi r square is equal to 100. Okay, pi r square is given 100 square centimeters. So instead of this, instead of pi r square, I will use 100. See here, 100 pi r square is given 100. So instead of pi r square, I will use 100. Okay, instead of pi r square 100 into h. Now here volume of cylindrical part, that is of the cylinder, h. Height over here, see here, height of the cylinder is 3. So we will write 3 here plus again 1 upon 3. Now again pi r square, again we will take 100 into h. This h is not given. That means the volume of the cone is not given. Okay, volume of the the height of the cone is not given. Okay, so we have to find out the height of the cone. We have to find out this height. So this h is not given, this height is not given, so keep it as it is equal to 500. Okay, now see here, multiply this. 100 into 3, 300 plus 1 multiplied by 100 will be 100. 100 upon 3, 100 upon 3, and this h that we have to find is equal to 500. Okay, now what we'll do is keep this as it is over here, and this 300, when you bring it on the right hand side, will become minus 300. So keep this as it is. This part you write it as it is. 100h upon 3 is equal to 500. This 300 plus 300, when you bring it here, will become minus 300. Okay, now again 100h upon 3 is equal to 500 minus 300, you will get 200. Okay, now what we will do is we will cross multiply here. Cross multiply here, that means see here, h is equal to, you multiply this, 200 multiplied by 3, and this 100h, that is in multiplication, 100 multiplied by h, multiplication will come here in division. Okay, see this cross multiplication, 200 h is equal to 200 multiplied by 3, and this 100 will come here in division. Now you can reduce this, these two zeros and these two zeros you will cancel. What is left is 2 multiplied by 3, that is h is equal to 2 3s are 6 centimeters. That means we got the height of the cone. See, height of the cylinder was already given. Height of the cylinder was given. Now we got the height of the cone. We got the height of the cone. That is how much it is? 6 centimeters we got. So now we can add this. Height of the cylinder is 3. Okay. Height of the cylinder is 3 and height of the cone is 6. That means we will add these two. 6 plus 3 is equal to 9. Okay. So that is what was asked. Find the total height of the figure. So total height of the figure is cylinder's height was 3. That is 3 centimeters. 3 plus the height of the cone we got 6. So 3 plus 6, 9. 9 centimeters. Understood? So we can write the final answer. The total height of the figure is 9 centimeters. Understood? Now see the 8th sum. In figure 7.11, a toy made from a hemisphere, a cylinder and a cone. So this is the toy. that is made from a hemisphere. So this is the hemisphere. Suppose this is the hemisphere. This part is the hemisphere here. Then you can see this is a cylinder and this is a cone. So joining these three figures, a toy is made. That is the hemisphere. This is the hemisphere, a cylinder and a cone. So what we will do is, in this question, we will add all the curved surface area. The curved surface, first we will find out curved surface area of hemisphere, then curved surface area of cylinder, and then we will find out the curved surface area of the cone, and then we will add all three. That is how we will get the total surface area of the toy, total area of the toy. Understood? So first what we will do is, we will add the first we will find out the curved surface area of hemisphere. So first thing, but what you have to write is, we will first write what is given here. The toy is made from a hemisphere, a cylinder and a cone. It's given here in the question. You can write, a toy is made from a hemisphere, a cylinder and a cone. Now see here, they have equal bases. The bases is equal. See here, a base of the hemisphere. This is the base of the hemisphere. The same thing is the base of the cylinder, plus same thing is the base of the cone. That means they have equal bases. Okay, if they have equal bases, their radius will also be the same. Okay, see here, the radius of the cone is given. Since their bases are equal, radius is given 3 centimeters over here. That means the radius of the cone, radius of the cylinder and radius of the hemisphere will also be the same. That is 3 centimeters. Okay, so first we will write that they have equal bases. All the figures just write all have equal bases. Okay, you can write all have equal bases. All have equal bases. Now since I said bases are equal, means the radius will also be same. Okay, so radius, therefore radius will be same. Radius is given 3 centimeters. Okay, they all have equal bases and radius is given 3 centimeters. Now we'll go in order. First we will find out the curved surface area of hemisphere. Okay, so we will write curved surface. First find out the curved surface area of cylinder, of hemisphere. 2 pi r square. Okay, curved surface area of hemisphere is equal to 2 pi r square. Now what we will do is, we will keep the pi as it is. Okay, don't because see, curved surface area, pi will, don't calculate it, keep it as it is. Curved surface area also you have pi, cylinder also you will have pi, and cone also you have pi. So don't calculate that, just keep it as it is. So 2 into pi into r square. R square is, r is 3 into 3. Okay, so here you get 3 3s are 9, 9 2s are 18 pi. Now since it is area, we will write square centimeters. Suppose this is your first equation. Understood? This is your first equation. We got the curved surface area of the hemisphere. We got the curved surface area of the hemisphere. How much is that? 18 pi. We got 18 pi. Next we will find out the cylinder. Okay, now we will find out the curved surface area of cylinder. Write down the formula. Curved surface area of cylinder is equal to 2 pi RH. Again over here also we will keep the pi as it is. 2 pi r. R is 3 into H. Now see here, cylinder, for the cylinder, this is the cylinder. For the cylinder, 3 is the common radius for all the three. For the hemisphere, for the cylinder and the cone. but height for the cylinder is 40. See here it is given 40. So instead of h we will write, for height we will write 40. Understood? So height of the cylinder is 40. Now multiply that. 2 3s are 6, 6 4s are 24. That means it becomes 240 pi. Pi again keep it as it is, and then area it is, so write square centimeters. Understood? This will be your second equation. Understood? See, now we got curved surface area of hemisphere, we got curved surface area of cylinder. How much we got? 240 pi. 240 pi. Now what is left? Now we have to find out the curved surface area of the cone. Okay, now we will find. But see here, for curved surface area, what is the formula for curved surface area of the cone? Pi RL. Okay, suppose the formula is pi RL. Now here, pi we have to keep it as it is. Radius is common, that is 3 it is. Okay, this is the formula for the curved surface area of the cone. Pi we will keep it as it is. Radius is given 3 centimeters. L we don't know, but we can find out L. See here in the figure, suppose this is a cone. Height is 4 centimeters. H is given. Radius is 3 centimeters. Now what we have to find? L, that is the slant height. This is the slant height. Okay, this is the slant height which we have to find. This is L. This is the slant height. So the formula we will use for that, what we will use? First we will say that let the slant height be L. First we will say let the slant height be L. Okay, let the slant height be L. So the formula to find out slant height is L square is equal to R square plus H square. Okay, L square is equal to R square plus H square. Now L we don't know, so leave that. R we know is 3 square plus H. Here, see this. The height of the cone is given, that is the perpendicular height is given. We have to find out the slant height. Perpendicular height is 4, that means H is 4 square. So 3 3s are 9 plus 4 4s are 16. That means L square we got 16 plus 9, 25. So therefore L is equal to, okay, L is equal to, when we take the square root from both the sides, L is equal to 5 5s is 25. So we get L is equal to 5. Now we got L. So now we can use this formula, curved surface area of cone, and find out the curved surface area of cone. So now we will use curved surface area of cone. Curved surface area of cone is pi R L. Okay, again here also we will write pi as it is. R is 3 centimeters. Okay, and L we got 5. So 5 3s are 15 pi square centimeter. See, and this is your third equation. Now see, we got the curved surface area of the hemisphere, then we got the curved surface area of the cylinder, and we also got the curved surface area of cone. How much it is? 15 pi. It is 15 pi. Now what we are going to do? The question is find the total area of the toy. So we will add these three and we will get the total area of the toy. So total area of the toy is equal to curved surface area of hemisphere plus curved surface area of cylinder plus curved surface area of cone. Okay, now what we will do is we will add all three. So first is what? Curved surface area of hemisphere. Hemisphere we got 18 pi plus curved surface area of cylinder. Cylinder we got 240 pi plus this 15. Curved surface area of cone. Cone we got 15 pi, and here you can write from 1, 2 and 3. From 1, 2 and 3. Okay. So what we will do is we will add all this. 18, 240 plus 15 and 18. We get 273. So we get 273 pi here. Okay. Keep the pi as it is. And then you write the unit. That is, since it is area, we will write square centimeters. Okay. So this is your final answer. You can also write, therefore area, total area of the toy is 273 pi square centimeters. Understood? It is an easy sum. What you have to do is just find the curved surface area of the hemisphere, then the curved surface area of the cylinder, and then curved surface area of the cone, and then add all the three areas and you'll find the total area of the toy. Okay, so we have finished sum number 8. Okay, now see the ninth sum. In the figure 7.12, a cylindrical wrapper of flat tablet is shown. Okay, this is the wrapper. Okay, this is the wrapper, and it contains flat tablets. Okay, it contains flat tablets. The radius of the tablet is 7 millimeters and its thickness is 5 millimeters. Okay, so now here it is in millimeters. How many such tablets are wrapped in the wrapper? Okay, now we have to find the number of tablets wrapped in the wrapper. Okay, now suppose, see, this is the wrapper given, and suppose this is the tablet. I'll draw the tablet here. Okay, suppose this is the tablet. Okay, this is the tablet. What they have said, the radius of the tablet is 7 millimeters. So see here, the radius is given 7 millimeters, and its thickness, how thick it is. So thickness is the height of here. Thickness is given 5 millimeters. Okay, now this is for the tablet. Radius is given 7 millimeters and the height is given that is the thickness, how thick the tablet is 5 millimeters. Okay, and for the wrapper, this is the wrapper, see here, the diameter is given here. Okay, the diameter is given 14 millimeters. Now we have to find the radius. So we know radius is half the diameter. So if this is 14, so the radius of the wrapper will be 7 millimeters. Okay, now here, this is the height. This is the height of the wrapper, of the cylindrical wrapper. Height of the cylindrical wrapper is 10 centimeters. So first what we will do is we will write everything that is given here. So solution, first we will write for the cylindrical wrapper, and then we will write for the cylindrical. Now see here, the tablet is also in the form of a cylinder. Okay, same shape it is in the cylindrical form. So we will write first for the cylindrical wrapper, and then we will say for the cylindrical tablet. Now for the cylindrical wrapper, now see the wrapper here. What is given is 14 millimeters. 14 millimeters is the diameter. Okay, suppose the diameter D is equal to 14 millimeters. Therefore radius will be what? Half of it. Radius will be 7 millimeters. Okay, radius is 7 millimeters. Now the height, see the height is given 10 centimeters. Height is equal to 10 centimeters. Now if you look at the question, all the units are in millimeters. See the tablet also here, all the units, the height, the thickness and the radius is in millimeters. The wrapper also, for the wrapper also radius we got millimeters, 7 millimeters, but the height is in centimeters. Okay, so we know that 1 centimeter is equal to 10 millimeters. So this 10 we are going to multiply with 10. Okay, so therefore this 10 centimeters, 10 we will multiply it with 10, we get 100. 10 tens are 100 millimeters. Okay, you can write there, since 1 centimeter is equal to 10 millimeters. Okay, 1 centimeter is 10, 2 centimeters 20, 3 centimeters 30. So same way 10 we will multiply it with 10, 10 tens are 100. Okay, So 10 centimeters will be 100 millimeters. Okay, so we have converted this. Now for the cylindrical wrapper, we got everything, we have written everything. Now we will write for the cylindrical tablet. For the cylindrical tablet. Now for the cylindrical tablet, what is given here? See, the radius is given. The radius of the tablet is 7 millimeters, so R. Now see here, you can also take capital letter. Now for the cylinder, I took small letters. Here you can even take capital letter. I will take suppose capital R for the radius of the cylindrical tablet. So capital R I am taking here for the tablet. 7. Radius is 7 millimeters. And the thickness, that is the height, is 5. Again capital H, 5 millimeters. Okay, now what I have done here, first I have written everything for the cylindrical wrapper, whatever is given here, and for the cylindrical tablet I have written what is given here, the height and the radius is given. Now what you do is, now what we have to find, how many such tablets, now how many such tablets are wrapped in this wrapper, how many tablets are there in this wrapper. So we will find the number of tablets wrapped in the wrapper. So write the number of tablets wrapped in the wrapper is equal to the we will find out this volume of the wrapper upon volume of the cylindrical tablet. Okay, we have to find how many tablets this can be wrapped in this wrapper. So we will use volume of the cylindrical wrapper upon volume of the cylindrical tablet. Now we know the volume of cylinder is pi r square h, So volume of cylinder, for volume of cylinder, cylindrical wrapper pi r square h, we have taken small letters only, so you can use pi r square h as it is, upon volume of cylindrical tablet. For the cylindrical tablet we use capital letters, so we can use again pi, but R I am taking capital here, R square, and H also capital. Understood? So see here, number of tablets wrapped in the wrapper is equal to volume of the cylinder upon volume of the tablet. Now both are cylindrical, so same formula is used here. But see here, pi and pi will get cancelled. No need to calculate that. This pi and this pi will get cancelled. Now what is left is R square H. Now see here, cylindrical wrapper R square H. R is 7, so we get 7 square. So 7 multiplied by 7 into H. H is 100. Okay, H is 100. We converted into centimeters, we converted into millimeters. So you have to take 100 upon, again R square H for the cylindrical tablet. Cylindrical tablet, again it is R is 7. 7 into 7 into H. H is 5 over here. Okay, now see here, this 7 and this 7 will get cancelled. This 7 and this 7 will get cancelled. This also we can reduce. 5 ones are 5, 5 2s are 10, and 5 zeros are 0. So what we get is 20 over here. We get 20. Now that is what was asked. Number of tablets wrapped in the wrapper. How much we got? 20. So that means, what was the question? How many such tablets are wrapped in the wrapper? You can write 20 tablets are wrapped in the wrapper. Okay, understood? What we did here first is we found the cylindrical wrapper. We wrote whatever was given for the cylindrical wrapper and for the cylindrical tablet. Then how to find the number of tablets in the wrapper is equal to volume of the cylindrical wrapper upon volume of the cylindrical tablet. Okay, then you can write down the formulas and put down their values and then find out. Okay, so we have finished sum number 9.